Good morning, precalculus class. This lesson today is on the conic section, the circle. Go ahead and start this warm-up. Questions 2 will be more difficult completing the square problems. All right, here are your answers. The C value for the first problem is 256. 32 divided by 2 is 16 squared is 256. The C value, or the perfect square, is in the second problem right here, 49/4. It's always going to be positive. It's an important thing to note because when you square a negative, it becomes positive. And of course, you always take this linear term and divide it by 2a. In this case, a is 1, and in this case, a was 1 as well. All right, the next problems were a lot more difficult completing the square problems. And let's go through this work. So in the first one, you have an a term not 1, so I group those together on this side and leave the -4 here. And then I pull out the 3, so you end up with 8/3 here. And then when you divide it by 2, you get 8/6, which is 4/3. And then when you square 4/3, you end up with 16/9. And if you add 16/9 to this side, you multiply it by 3, and you get 16/3 that's being added to this side. That turns into your x minus 8/6. 8 over double this, or divide by 2, and you get 8/6, which is 4/3. This 4/3 squared was this here. And then I divided by 3 on this side to end up with 4/9. Then you can solve it by square rooting both sides, moving over the 4/3, and you just add them and then subtract them to get your answers of 2 and 2/3. On the one here, some bigger numbers, but what you're doing here is you're also pulling out the 10, so you get 4/10 or 2/5. 2/5 divided by 2 is 2/10, which is 1/5. And when you square it, you get 1/25. When you do the perfect square of this, you get the 1/5. So that all kind of holds together. What you actually added, though, was only 2/5, because 10 times 10 over 25 is simplified to 2/5. You have to get a common denominator. You get -338/5 here. Not a very pretty problem. Divided by 10, you get -338/50, which I could have simplified sooner, but it ends up there's a common 2 factor, right, which is 169/25. So it actually makes it look a little better as you move through the problem, because those are perfect squares. You end up with 13/5. So you have -1/5 plus or minus I. Don't forget, if you have a negative and you're square rooting it, out pops the I, your imaginary unit, and you end up with I times 13/5, and we can combine that into one answer. Actually, it's 2 complex answers. Let me just fix this. Plus or minus 13i there. All right, that's your warm-up, long one. Okay, in the lesson today, we've got our general equation of a conic section here, and we're going to focus in on the circle. Note, you know a general equation of a conic is a circle if the a and the c, your coefficients of x squared and y squared, are equal. So a and c have to be equal, like a 2 and a 2, or a -3 and a 3, or a 1 and a 1. And the product can't be 0, so they have to both exist. You can't just have an x squared term and not a y squared term. If that's the case, then you're going to be down at the parabola. So these are the requirements where you can quickly look at the general equation and say, oh, it's a circle. And then we're going to talk more about the standard form of that on the next slide. All right, the definition of a circle: it's the set of points in the xy plane that are some fixed distance r, called the radius, from some fixed point, and we're going to use the ordered pair variables h, k. And that fixed distance r is the same, every point on the circle is that same distance away. If we were asked to draw a circle, given the center, hk, we could plot r above, to the right, below, and to the left, and be able to quickly sketch the graph of a circle. So using that information that we were given, the center HK can go into the standard form of the equation of a circle right here and here, and of course the R length goes here. So for instance, if you were given a circle with a center at -1, 3, and a radius of 5, and I were to plug those values in, you'd end up with x minus -1, so +1 squared, plus y minus 3 squared equals r squared, which is 5 squared, or 25. And now you should be able to identify, looking at the equation in standard form, quickly that your HK, or center, is at -1, -1, +3, and that the radius is the square root of 25, or 5. So these symbols here end up being the opposite sign of where the center is. All right, another definition you should know is that of a tangent line. That's here. A tangent is a line in the same plane as a circle or any curve that intersects the circle at exactly one point. The point of tangency is the point of intersection. So for instance, this is a tangent line through this tangent point, or point of tangency. But let's say I wanted a tangent line right through this point. There's only one tangent line through that point, and it would be the line that ends up being right here. It could only touch the circle once. If that was turned, that line was turned, it would be crossing the circle more than once. A neat rule around the tangent line is anytime you connect a point of tangency to the center of the circle, it forms a perpendicular line. That radius is perpendicular to the tangent line through that point. You will need this fact or this knowledge on your homework tonight. All right, so here's an example I would like you to try on your own. Find the center and radius of the circle and then draw a graph of it. Pause the video now and then check your work. Here is the center, so -1, +3, and the radius is the square root of 16, or 4. On the next slide, we will see the graph of it. All right, here's the graph. You could just follow steps. Plot the center of the circle, which was -1, 3, so over 1, up 3. And then plot your points in 4 spaces, moving the radius, which in this case was 4. So from this point, I'm going to walk up 4. 1, 2, 3, 4, and there's -1, 7. I'm going to walk over 4. 1, 2, 3, 4. So you end up at 3, 3, down 4, 1, 2, 3, 4, -1, -1, and left 4, 1, 2, 3, 4. And so you're at -5, 3. And that will be good enough for a sketch for me. If you're asked to do this, just plot those 4 key points and then connect the circle the best you can. You don't need to use a compass for your homework. This next example is taking your general form of your circle and turning it into the standard form by completing the square and then identifying center, radius, and graphing it. We'll do this example together. First thing I want you to note is I look at the coefficients of the x squared and the y squared terms, and this is your a value and your c value, and as long as those are equal, I know it's a circle. So it has to be equal and same sign. So in this case, they are both 1. That's an equal number. I know I have a circle. The other thing is, if they were something like 2 and 2, you could just divide out the 2 altogether and just put them back to 1 when it's a circle. So let's go through this work though. The first thing we need to do is group our terms together. So we're going to have x squared minus 4x, and we'll be completing the square here. So we need our c value, or the number that is the perfect square. And then we have our y term, and we'll be completing the square there. We're going to move the 5 to the right. If we add these 2 values, we're going to have to add 2 values to the other side to keep the equation in balance. So let's complete the square. -4 divided by 2 is -2. -2 squared is a 4. So I'm adding 4. Here we have an 8 divided by 2 is 4. 4 squared is 16. Great. Okay, so now I complete the square on both of these separately, and we get our perfect square binomial. Check your work. This value of -2 is just -4 divided by 2. And of course here it's y plus 8 divided by 2, or 4 squared. Don't forget those are squared. And then we add these terms together. We end up with a nice 25. Hey, I know that's a circle. My center is at the HK values, which is +2, -4. And my radius is the square root of 25, or 5. So if we need to draw a quick sketch of this, we are going to do so. I'm going to give myself a little coordinate plane. I'm going to plot 2 down 4. Ooh, I'm going to run out of space. But now what I'll do, I'll use another color, is I'm going to walk up 5, make a little X. I'm going to walk over 5, make a little X, left 5, make a little X, and I'll move this up some more. And we'll go down 5. 1, 2, 3, 4, 5, make a little X, and then draw the best circle you can. And there you have it. There is the work on that example. And pretty much your homework is going to be looking at problems like these. The hardest ones you'll get is where you are completing the square twice, so you can identify the general form to the standard form.